Okay, good evening all. So,
Yes, sir.
a warm welcome to all for Robotics. So, is organized by I welcome all the participants, all the faculty members for this web series, so webinar sections. And one more thing is the computer section or computer vision. So, thing is like how the human is actually being the object. Similar when we are actually seeing the pen, you can be understand this is a pen or this is a what to say mobile phone, whatever it may be. Similarly, how the system, how the computer is actually understanding this is an object belongs to this name. So this is actually the importance of understanding the computer vision and everything. So we have an eminent speaker with us, Mr. Vibul Nath. So I welcome sir, Vibul sir,
Thank you.
and I hand over the section to the Vibul sir, and I think he will take the best class for you, and you can ask the doubt regarding the vision and image processing and everything. He's one of the expert, and he's actually CEO of organization called the Leap, and we can start the section. Sir, we can start the section. Hand over to you.
Okay, thank you, sir.
Okay.
So, as told myself, Vipulnath, and I represent this organization called LEAP. So, LEAP is basically computer vision and robotics based system developers. We are working on our dashboard cams and also on a patented technology right now. And Leap for Learn is our training wing. Currently, we are providing training in the field of computer vision, Python, machine learning, and data science. So if you find us interesting, capable, or motivating after this session, you can definitely join our programs. So I would like to extend my extreme gratitude towards Akhil sir and the Robotics Club for helping us organize this webinar on computer vision and robotics. So the main agenda for today would be to make sure that you understand implementing computer vision with the help of OpenCV and Python is really simple. Okay. Sir, audible അല്ലേ? കേൾക്കുന്നില്ലേ?
കേൾക്കുന്നുണ്ട്. Sir, continue. You can continue.
Okay, after that, we would be indulging ourselves with a small session of robotics, discuss different types and their applications, right? So without an ado, let us begin. I'm going to share my screen. If you have any doubt, you can ask me. Okay.
Sorry, sir. Hriday sir. Hriday sir, can you put the mouse? Okay. Okay, you can continue.
Sir, can you see my presentation?
Yes, it is visible.
Okay. So let us start. You can always find us at leap4learn.com. Our main topics of today would be computer vision, a small OpenCV based practical session. Then we would be discussing about robotics, different types and applications of robot. Okay, let us start with a story, the tale of Talos. Talos was a giant bronze humanoid, a character from Greek mythology. One peculiar thing about Talos was that he had a long tube running from his head to his toe containing a fluid called as E-core. Now, E-core is something that powered Talos. E-core gave life to Talos. E-core is what made him think, talk, act. In later part of the story, Talos was killed by letting E-core flow out of him. So you might be actually wondering, what is the point of this story? Why have I told this story in the first place? To be frank, this story is of little importance. But the point here is that the idea of robotics or the idea of making machines see or think is not actually the discovery of our generation. We have been thinking about them for past millenniums. It is in our blood and bones to fantasize about science fiction. But what made it possible for our generation is the advancement in science and technology. It would be unfair to point out a particular street, though the advancement in microchips and microcontrollers might have catalyzed our dreams to success. What I mean is that our version of Talos 2.0, if we are ever going to have one, would have its E-core replaced by a simple Arduino. Now that was a bit of mythology I thought I should start with. Now let us get serious and start talking about what is computer vision and why is it important. So computer vision is just making machines see like us, nothing more. Why is it important? Imagine the car you are driving. can see even when you lost concentration while driving. Imagine a microscope can count millions of cells within a second. Imagine a small camera assisting a blind person while crossing a busy street. I hope these examples are more than enough to understand the importance of computer vision in our daily lives. So let me very briefly discuss about the evolutionary tree, right? It all started as a single light sensitive protein on the tail of euglena, helping euglena steer towards the direction of sunlight. After that, billions of years of evolution took place, and it took place differently for different organisms. What I mean is that the visual capability of a human eye is very much different from what an eagle's eye can see or perceive. It is much different from what a nocturnal being's eye is capable of. In any case, it is without any doubt accepted that vision is the most complex, sophisticated, and the most advanced sensor in the entire animal kingdom. Similarly, a bit of evolution, or a rather better term would be innovation, has occurred in the case of cameras that we see now. Starting from pinholes, the cameras which we used to call as camera obscuras, and then gently escalated towards the digital cameras that we see now. So digital cameras are what made computer vision possible in the first place. Sorry. Just a second. Sir, I think someone just drew something. Let me share this. Okay, now if we are going to discuss about the two most competing technologies in the field of computer vision sensors, they would be CCD technology and CMOS technology, where CCD stands for charge coupled devices and CMOS stands for complementary metal oxide semiconductor devices. So if you ask me who's actually winning the race, I would say CMOS always have an upper hand, because CMOS can provide us with digital outputs, whereas CCD provides us with analog outputs. CMOS requires less power compared with CCD counterpart. Anyway, I'm not going to extend on these two topics. If you find them interesting, or if you would like to know more about these two topics, you can definitely go through the link I have provided below. Now, it is fairly a very relevant question to ask someone. Why should he or she learn Python? Now, let us start with the simplest, because Python is the most easiest programming language anyone can learn. And recent internet researchers suggest Python has overtaken C, C++, R, and many other programming languages in the case of its popularity. It also has got vast amount of library support and great community support too, which means if you are going to stumble on any issue dealing with Python, you will definitely get help in the internet for free. And most importantly, if you know Python, then you can easily dive into different hot fields that are AI, deep learning, data science, machine learning, computer vision, robotics, and whatnot. Because almost everything has got Python background. And it is for sure that you gain access to millions of pixels of information in a second or in a click while you capture an image. Excuse me. Any doubt? I'm not able to hear.
ഇല്ല ചെറിയൊരു ഇതേ ഉള്ളൂ, കുഴപ്പമില്ല.
Can I continue?
Audible ആണ്.
Okay.
Hello.
So what I'm talking about is that a necessity for dedicated hardware. Hello.
ഹലോ.
Sir,
ഒരു ലാഗിങ് വരുന്നുണ്ട് കേട്ടോ. നെറ്റ്വർക്ക് ഇഷ്യൂ ആണെന്ന് തോന്നുന്നു.
എനിക്ക് ഇടയ്ക്ക് ഇങ്ങനെ വോയിസ് കട്ടായി കയറി വരുന്നുണ്ട്. ഞാനത് കാരണമാണ് വീഡിയോ ഓഫ് ആക്കിയത്. വീഡിയോ കണ്ടിന്യൂ ചെയ്യാലോ അല്ലെ?
continue.
Okay. So dedicated hardware നമുക്ക് ഈ computer vision run ചെയ്യാൻ അത്യാവശ്യമായിട്ട് വരും because we are gaining huge amount of data, and these data cannot be processed in real time with the help of our traditional CPUs. We need GPUs, maybe graphic processing units, or TPUs, which are tensor processing units. So there are a lot of single board computers available for rapid prototyping, like NVIDIA's Jetson platform that has got GPUs. Now there are Raspberry Pis, Latte Pandas, or Droids. Now the most beautiful thing about all these hardware platforms are that all of them have got Python integrated with it. So I suggest that you really should shift into Python, or you should start learning Python right away. And recent market research or analysis are saying that most of the companies, more than 90% of these companies, are shifting their workforce into Python related, right? So that is one advantage why I suggest that you should all know about Python or learn Python. Anyway, continuing on. So what is OpenCV? OpenCV is basically a library of computer vision functions that would help you run computer vision algorithms real time. So it would not be a new thing to say a computer science engineer that about libraries, but for those who are not familiar with computer programming, I would say libraries are just kind of functions or a repository of functions where you can look and use those functions to run or make your algorithm run real time, right? So before we go into any session of coding, I would want you all to understand that an image contains 3 channels, red, green, and blue, as shown in the figure, right? A computer sees them as a stack of matrices aligned as shown in the figure. Now, if you look at the intensity values, each matrix have each pixels, and that pixel intensity can range between 0 to 255, where 0 represents dark and 255 represents bright. So assume that this was 255, green was at 0, and blue was at 0. Right now, the image at that point would have red color because 255 contributes more in the case of color, and that 255 happens to be on your red channel, right? So this is how you see basically a colored image. Colored image contains 3 channels, red, blue, and green. Right? The intensity values range between 0 to 255, where 0 stands for dark and 255 stands for bright, right? So I hope you can see the video. This is what I'm going to do my work on. So basically I have this video, and with the help of OpenCV and Python, I'm going to track and localize the position of these ants, right? So it might look a difficult task, but I'm going to explain the sequence of operations I have done. If I'm going to brainstorm on this idea, the first thing to come to my mind would be to do background subtraction. So background subtraction basically eliminates all the backgrounds and extract only the foreground elements, or the moving elements, or the moving ants or insects inside our video, right? So different people might have different approaches. I'm going to stick with background subtraction. So clear അല്ലേ സർ എല്ലാവർക്കും? വോയിസ് കേൾക്കുന്നില്ലേ പ്രസന്റേഷൻ? കാരണം ഞാൻ ഈ അൽഗോരിതത്തിലോട്ട് കടക്കാൻ പോകുന്നു.
Yes, കേൾക്കുന്നുണ്ട് clear ആണ്.
Okay. Now the first thing I did was to convert a colored image into a grayscale image. Now color image has 3 channels. When you convert a colored image into a single channel grayscale image, you actually reduces the cost of computation. So how do you do that? How are you actually reducing the cost of computation? Imagine an arithmetic operation being done on 3 matrices, and imagine the same arithmetic operation being done on a single matrix. It is very much evident from the basic math itself that the operation being done on a single matrix is going to run 3 times faster than compared to the operation or the same operation being done on 3 matrices, right? So basically, if you look at these 2 images, it is pretty much evident what is the difference between a colored image and a grayscale image. So in colored image, you can definitely see that there are informations of color. Right now, this is a leaf because the color of that part is actually green. Now, when you look at the grayscale image, it is hard to identify which color that part belongs to. So one problem is that you are going to lose the information about the color. But since color is not our valid data point, we are interested in only localizing and tracking the moving ant or element. Now, if you look at the grayscale image, the information we are seeking is pretty much eminent here. So it is pretty much intact here. So one advantage of converting colored image into grayscale image is that you can reduce the cost of computation. And also, if the information that you are seeking is not lost, then this is one good way to deal with images or videos, right? Now, the second thing I did was to do background subtraction. So if you are watching this video in a mobile phone, then you might need to zoom in on this image, right? So that you can see, individual white spots here and there. Now, coming to background subtraction is basically subtracting the previous frame from the current frame or previous image from the current image, because a video is just a sequence of images, right? Now, if you look at the image on the left side, you can see that after doing background subtraction on the previous grayscale image, this is what I got. You can see the information of the ant or the foreground element has been successfully extracted out. All the information on the background is eliminated, right? But we have a problem now. So if you are going to zoom in around here or on a closer inspection, you can find that there are a lot of individual pixel intensities or white pixels springing up at different parts of this image. These are called noises because these are not any contribution of any of the moving elements or the foreground elements. These are noises because these can be contributed by the, yes, it's not audible. Not actually audible. Can you chat if there is no? Ma'am, actually, you are not audible. Can you chat if there is an option to chat? You can chat. Please click on chat so that I can see, because your voice was breaking. You have any doubt? Sir, കേൾക്കുന്നുണ്ടോ?
കേൾക്കുന്നുണ്ട്.
മാഡം എന്താ പറഞ്ഞത് ഞാൻ കേട്ടില്ല. അപ്പൊ ഡൗട്ട് ആയിരുന്നു.
ഇല്ല, ഞാൻ കേട്ടില്ല. I don't know what she is saying.
Okay.
Anyway, we can neglect it. Otherwise, if you have any students or any people have any doubt, you can be put in the chat box. Okay, we can continue.
Okay. So these individual noises can happen due to a variety of reasons. It can be due to variation in illumination intensity, right? Or it can be due to the fault in your data acquisition system. In any case, when you are dealing with engineering systems, it should be considered as a prime importance to remove all these noises. And in normal engineering terminology, removing these noises are called as filtering. Right? Now, OpenCV provides us with a lot of filters, like Gaussian filters. There are average filters, bilateral or median filters. In any of these filtering methodologies, the first thing you have to do is initiate a kernel or a window, right? A kernel is, in the case with respect to the image on the left, a kernel is actually our yellow window. And this yellow window is going to scan the entire green image, right? So right now, the dimension of this yellow kernel is 3 by 3. It might have different elements, right? So the operation of scanning the green image or our original image from top to bottom is what we call as convolution. So in the case of average filters, whatever pixel intensities of the original image are inside this yellow window gets averaged. So if you have any doubt, you can ask or you can chat. Anyway, I'm not going to extend on filtering methodologies because I haven't used any of these filters. Instead, I have used a sequence of morphological operations called as erosion and dilation. Sir, കുറച്ച് speed കൂടുതലാണ്. Should I modulate it?
No, it's okay. It's okay.
So let the image speak for itself. Erosion is a method of removing the noises. From the image itself, it is clear that you had a thick J, and after the operation of erosion, it is pretty much obvious that right now you got a thin J, right? So if you look at the image on in the thick J, the operation of erosion has eroded away the white pixel intensity, white pixel intensities from the edges of the thick J, resulting in a thin J, right? So after applying erosion onto my image or my data set, this is what I got. So if you closely look at the image, you can see that we have successfully eliminated all the individual pixel intensity noises, right? But there is one trade-off, and the trade-off is that the size or the dimension of the information that we are seeking, the insect, right, or the foreground element has reduced, because erosion has the tendency to erode away the information also, right? Now, one thing to get over this issue is to apply a sequence of dilation, right? Dilation is pretty much obvious from the image that you have a thin J. After the operation of dilation, you get a thick J, right? Now, this is what happens if I apply dilation onto my previous image, right? If I apply dilation onto my this image, eroded image, this is what I get. So it is pretty much clear from the image that right now the information of the insect has increased. കേൾക്കുന്നില്ലേ?
It's audible.
Okay. So if you look at the edges of this and information, you can see there are grayscale intensities. So if you can't see, I suggest you zoom in, right, a bit. So this can be considered as a noise, and this can be eliminated with the help of what you call as thresholding. So thresholding basically sets a threshold. So basically a thresholding operation turns the image into a binary format. So it might contain only zeros or ones, or maybe zeros or 255s, right? It depends on the type of flag we are actually inputting in the coding structure, right? Now, the basic understanding of the operation of thresholding is that we have to primarily set a threshold set point. Then that threshold set point is getting compared with each individual pixels. So if any of the pixel intensities are above threshold set point, it gets set to 255 or Boolean true or maybe 1. If it is below the threshold set point, then it is set to Boolean false, binary 0, resulting in only two intensities, that is white and black. It also filters out unwanted noises. I hope the operation of thresholding is pretty much clear. I mean, we have been using thresholding from the first year of our engineering terms anyway. So thresholding is a basic simple operation. So we have a threshold set point. Everything above threshold set point gets some fixed value. Everything below threshold set point gets another fixed value. Right? Now, what is left is actually the operation of what you call tracking and localizing, right? So we need to find out where the ant is inside our image, right? This image is basically, as I told, would be considered as a matrix by our computer. So it might have maybe 1,000 rows and maybe 2,000 columns, right? So tracking and localizing means find an exact point which can represent this entire information or the element that is moving. So in the case of this ant, this might be at the 1,000th row or maybe 800th row and maybe at the 600th column. So that is a point which is going to represent this particular ant inside our frame. Now that is what we call as localizing. Now there are two methods we can utilize to localize and track the foreground elements. One is contours and another is moments. So contours are curves joining continuous points with same intensity values. So if you look at the previous image, you can see the white spot would be having the same intensity, that is 255, and 0 would be having all the intensities, that is 0, mean dark pixels, right? But contours find out the borders of these white pixel intensity values, right? So if I'm going to apply contours, I will get two contours, contour 1 here and contour 2 here, right? So that is what my contour function has done, contour 1 here and contour 2 here, right? Now, we cannot actually rely on the contour function to track and localize, because contours are going to give us, lot of number of points. Instead, to localize, we only need single point. So for a better localizing, we should have only a single point. That single point should represent the entire foreground element. So what we have to do is find out the moments. Assume that you are having a black background image with two white spots. Now, if you are going to apply contours onto these images, you will find two contours, contour 1 here and contour 2 here, right? Now, moments are actually the spatial concentration of pixels. Moments gives out the information of spatial concentration. So moment function returns out simple parameters like M01, M10, or M00, with the help of which you can actually find out the centroid, maybe the circumference, maybe the surface area, or the perimeter of individual contours. Right now, after applying contours onto this image, you found out two contours, contour 1 here and contour 2 here. And into those contours, I'm going to apply moments. And for each individual moments, I might find my centroid for the first contour in the yellow region and for the second contour in the green region. Any doubt? Okay. So if I am not applying contours, then directly finding out the moments. So my moments consider this image as a single contour. In that case, I might get my centroid at this red region, right? So that is how we are going to do tracking and localizing with the help of OpenCV and Python. So is that clear? Any discussion if required on, or if you have any doubt on the concept we have told right now, you can ask. And I am going to shift to my Python notebook, Jupyter notebook. Right now I am in my Anaconda Navigator. So any doubt, anyone? Any doubt undo? Or should I change my space or anything? Any suggestions? ആർക്കെങ്കിലും എന്തെങ്കിലും സജഷൻസ് ഉണ്ടെങ്കിൽ പറയാം. Can chat. Or sir, can I continue?
Yes, you can continue.
Sir, ഇപ്പോൾ Python കാണുന്നില്ലേ?
കാണുന്നുണ്ട്.
Okay, the first thing in any language is importing the necessary libraries. So I'm going to start with importing the OpenCV library and the NumPy library. Import CV2. CV2 imports the OpenCV library. I'm going to import NumPy, which is numerical Python library. Right. So NumPy is an optimized library which works on matrices or arrays, because we know an image is a matrix. In a computer sees an image as a matrix, right? Now, the next thing is that I have to read the videos, which is here, multi-n.mp4 in the library, into my workspace. Right? So I'm going to use, hello? Okay, so I'm going to use my OpenCV, initiate a cap object to read the video. Cap equals cv2 dot video capture. I'm going to pass in the name of the file, which is multi-and.mp4, right? multi-and.mp4, right? Now I'm expecting that I have initiated my cap object, and my cap object is going to have the video multi-and.mp4 inside it. The next thing is that to do any further computer vision algorithms, I have to extract individual frames or images from this video, because a video is a sequence of images, right? So for that, I have to start a while loop, while cap dot is opened, which means if cap dot is opened is saying that if cap has got a value or maybe an image to return, then I am going to return the image into what we call a color image variable cap dot read. So this simple step cap dot read is going to read individual images into, and it is going to save those images into color image variable, and the return would be true if cap.read has got an image to return, and the return would be false if cap.read doesn't have an image to return. In that case, if not return, which means if there is no return, meaning if there is no image to return, then I'm going to break out of the entire loop. Right? The next thing is that I'm going to display this image cv2.imshow. I'm going to name the frame as window, comma, I'm going to display the color image, right? Now, most of the programming languages, this bit of code is more than enough, but OpenCV demands that you add few extra bits of code to make this run smoother. So it starts with a condition. If cv2 dot wait key, mean after showing the image, color image, I'm going to wait for maybe 87 milliseconds or 80 milliseconds, it depends. And what I'm going to do is I'm going to check whether I'm going to press port Q, which means after displaying the image, I'm going to wait for 87 milliseconds. And in those 87 milliseconds, or within these 87 milliseconds, if I'm going to press Q for quit, then I'm going to break out of the entire while loop. Right? Now, OpenCV demand that you release the cap object you have initiated, release, and also destroy all windows. So I'm going to just give you a glimpse of what this code does. Cap.video capture is going to capture the video from the library, and it is going to store in the cap object. Now, while loop is initiated to extract individual images from the video, and that individual images get stored inside the variable called as color image. Now I'm going to display those color image with the help of IAMShow function. After displaying, I will be waiting for 87 milliseconds, and if I'm going to press Q for quit, then I'm going to break out of the loop and destroy all the windows that I have popped up for showing the image. So if I run this code, hopefully you can see. Can you see the video? Sir, video കാണുന്നുണ്ടോ?
ഇല്ല വരുന്നില്ല.
ഇതില് സ്റ്റോപ്പ് ഷെയർ കൊടുക്കുന്നത് എന്റെ സ്ക്രീൻ ഷെയർ ചെയ്യാനുള്ള ഓപ്ഷൻ ഉണ്ടോ?
ആ സ്ക്രീൻ ഷെയർ ഓപ്ഷൻ ഉണ്ടല്ലോ. You can share the screen.
Okay, sir, ഇപ്പോ കാണുന്നുണ്ടോ?
ഇപ്പോ വരുന്നുണ്ട്. Okay, yeah.
Okay, okay, then I am now going to press Q for quit. ഇപ്പോ എന്റെ പൈത്തൺ നോട്ട്ബുക്ക് കാണുന്നുണ്ടോ?
Yes.
Okay,
yes.
normally ഞങ്ങൾ ഗൂഗിൾ മീറ്റിലാണ് മീറ്റിംഗ് കണ്ടക്ട് ചെയ്യാറ്. അപ്പോൾ അതിന്റെ ചെറിയൊരു ഇഷ്യൂ ഉണ്ട്.
Okay.
Anyway, now we are going to do what is called our computer vision algorithms. Now we started with converting the image into grayscale image, right? So gray image equals cv2.cvt. I mean cv2.cvt color. I'm going to convert my color image variable right into cv2.color bgr. So this is actually means standard code for converting the colored image into grayscale image, and the bgr to gray is the flag we are going to give to convert the color image into grayscale. So if I'm going to display the grayscale image, just a second, cvt, okay, sorry, cvt color So can you see the image now? So video കാണുന്നുണ്ടോ?
Yes, better.
Okay. Okay, this is how this is the difference between a color image and a grayscale image. You can see the information of the grass. I mean, the color information of the grass is being lost. But the information right now that we are seeking is the information of the ant, which is intact, right? Okay. Now, what we did next was to do background subtraction. So for doing background subtraction, I have to initiate a background subtracting object, BGSO equals cv2 dot create background subtractor, and I'm going to use a mix of Gaussian. There are different types of background subtraction available. One is Gaussian, and this is a mix of Gaussian. So it's conceptually hard, but basically what BGSO does is it approximates that the background is having a Gaussian distribution, and based on that you are going to do your background subtraction. And previously I said that basically applying background subtraction is subtracting the previous image from the current image, right? It actually if you are going to do that, it actually gives you a lot of errors and multiple lines or ridges. Anyway, background subtraction, which is mix of Gaussian, is the most best in the case. The OpenCV currently is providing. So you can use a mix of Gaussian and mix of Gaussian background subtraction. Now BGS background subtracted image. Now background subtracted image equals BGSO background subtracting object dot apply. I'm going to apply it on my grayscale image. Now, if I'm going to display my background subtracted image, hopefully you can see that I have eliminated all the backgrounds and extracted only the foreground elements. So you can see the information about the ants are intact. But if you look closely, you can find there are a lot of pixel intensity noises. These can be removed with a sequence of operations called as erosion and dilation. So as I told, for applying erosion or dilation, the first thing I have to do is to initialize a kernel that is going to scan the entire image, right? So I'm going to initialize a kernel for erosion, which is equal to CV mean. I'm going to create a NumPy array because it's basically a matrix, and NumPy can be used to create those metrics. np.ones of I'm going to create a kernel of size 2 by 2, which would be having 2 columns and 2 rows, and each of the 4 elements or each of the element would be 1. That is why np.ones. If I'm going to give np.zeros, then all the elements would be 0, right? Now I'm going to create a 2 by 2 kernel np.uint8, which means I'm going to explicitly define what kind of data type I'm going to use. So mostly the images are 8-bit in nature. So the kernel I'm going to make is also would be in unsigned integer 8 format, right? So after initializing the kernel for erosion, I'm going to apply this onto my background subtracted image, right? For that, eroded image equals cv2.erode. I'm going to pass in the background subtracted image, on which I'm going to do my erosion, and kernel for erosion, erosion, and I'm going to pass in the iterations equals. Currently, I'm going to pass in the iterations as 2, right? So iteration equals 2 means the kernel is going to scan the entire image 2 times, right? So if I run this code, if I'm going to display the eroded image, and on this code, hopefully you can see I have eliminated all the noises. But the trade-off here is that I have subsequently reduced the size of the information or the foreground elements. In our case, the ant or the insect, right? So we have to gain back those dimensions. And what we are going to do is to apply what you call as dilation. So even for dilation, I have to initialize a kernel for dilation. Kernel for dilation np.ones of I'm going to consider 4,4 and np dot unsigned integer 8. So you might be actually wondering, I have given different sizes for erosion kernel, which is 2 by 2. And for the dilation kernel, I have given the size as 4,4. Right? So one is having 16 elements and erosion kernel is having 4 elements. So the thing is that the choice of your kernel depends on the type of applications you are using this for, right? And most importantly, since you are dealing with single pixel noises, you can only give 2 by 2 kernel or maybe a lesser dimension. Because if you're going to give a greater dimension like 4 by 4, the greater information of the ants would be eroded away, right? So if you want to dilate a greater region, you can give a greater size to the dilation kernel. I hope it is understood. Any doubt you can ask or you can chat. Any doubt? Sir, can I continue? Doubt ഉണ്ടെങ്കിൽ ചോദിക്കാം ആർക്കെങ്കിലും. Anyone? Someone is asking something. Doubt ഉണ്ടോ? Voice കേൾക്കുന്നില്ല. Chat ചെയ്യാൻ പറ്റുമോ?
Okay, anybody have the doubt? Can we put your doubts in chat box? Okay, at the end of the section, we can be discuss otherwise.
So I think I should continue. Let's continue.
Yes, continue.
Okay, then I'm going to display, I'm going to do dilation onto my image, dilation image equal to cv2 dot dilate. Now I'm going to do dilation onto my eroded image because it's actually a sequence of operation. Then I'm going to pass in my kernel for dilation, dilation, right? So I think, okay, sorry, I have kernel for dilation. Then I'm going to pass in the iterations equals 5, right? Now, if I'm going to display my dilated image, hopefully you can see the difference from the previous case. Right now, we have bigger size of informations, right? I would like to show you how it would vary if I'm going to give the dilation count as 50 and display the image. So for the count of iterations, which is 15, we are getting bigger information. We are regaining the size, entirely much bigger. But the problem is that we lost the structural integrity or the shape of the ant, and in our case, it is not relevant, right? Because we only need to localize. We only need to find the position where these ants are, right? Maybe I'm going to go with 5 as my iteration count, right? The next thing, if I'm going to run this again, you can see there are, grayscale intensity noises, and these can be removed with the help of what we call as thresholding. The next thing I'm going to do is the operation of thresholding, right? So for doing thresholding, you have a standard formula, return, comma, thresh image equals cv2 dot threshold. I'm going to do threshold on my dilated image. And I am going to pass in the threshold set point as 127. So whatever pixel intensities is above 127 gets set to 255. Whatever is below 127 get set to 0. Right? 255 is the intensity I'm going to set if it is above. And I'm going to pass in what we call as the flag cv2 dot thresh binary, which means my threshold image would be of its binary format. THR, if I'm going to display the threshold image, hopefully this is what I get. I have eliminated all the grayscale intensity noises, and I have, extracted out only what you call the moving ant information or where the ants are, right? The next step we are going to do is what you call find out the contours. And with the help of contours, we are going to find out the centroid of individual contours, right? For finding out the contours, there are simple function called as find contours. So contour function gives out two outputs. One is contours and another is hierarchy. Contours, comma, hierarchy, because we need space for both of those outputs to get stored. Right? cv2 dot find contours. Sorry. Okay, sorry. CV2.find contours. So I'm going to find the contours from my thresholded image. Then I'm going to pass in the retrieval method CV2.retrieve, and it's going to use tree retrieval methods. So you might be wondering what is actually this tree retrieval method. So I have actually told you there are two outputs. One is contour, and another one would be hierarchy. So contours give you the information of all the connected pixels or the boundary pixels, right? All the positions of those pixels. So what is hierarchy? So if you are going to use the retrieval method, which is tree, CV2.retrieval tree method, then you would get the information of the hierarchy. So imagine that you are having a rectangle inside a rectangle, right? In that case, the contour function definitely would be returning two contours, a contour of the outer rectangle, and inside that rectangle, you would be having a contour of the inner rectangle. So retrieval method gives you the information of hierarchy, and hierarchy gives you the information which contour is the parent contour and which contour is the child contour, right? So I hope it is understood. The next thing is I'm going to pass in the approximation method, which is chain approx symbol. So in case if you are wondering what is an approximation method, assume that your contour is having a shape of line, right? A normal find contours function would return 100 points maybe for drawing that single line. But from the basic math, it is very much understood. To draw a line, you only need 2 points, and rest of all the 98 points are irrelevant. So basically, an approximation method or the symbol chain approximation method gives you only the relevant amount of points to draw a contour, right? Right now, if you implement this code, the contours will have the information of all the contours inside our image. Now, to extract individual images, I have to use a for loop. For C in contours, right? I'm going to draw the contours, right? For C in contours, what I'm going to do is CV2 dot draw CV2 dot draw contours. I'm going to draw it on my color image so that I can give what you call the color and the dimension, right? I'm going to draw it on my color image, and the OpenCV demands that you pass in the individual contours as a list into the function. And I'm going to give the next input as -1, which means every point in the C list has to be considered, right? Then I'm going to pass in the color. I mean, which color I have to draw the contour on. So assume that BGR, I have to give blue color, then 255 for B, G0 and red 0. And the next is the thickness of the contour I'm going to draw. I'm going to give it 2 pixel thick. Any doubt? Okay, then what I'm going to do is I'm going to display the color image, right? So hopefully if you run this code, you can see I have drawn my contours around each ants, but still I haven't done the actual localization or in tracking. Contours gives you a lot of number of points, right? So for localizing or for tracking, you need exactly a single point, which can be a representative of all these points. Now, to get those points, I have to what I have to do is apply moments onto my individual contours. So I'm going to pass m equals cv2 dot moments. Then I'm going to pass in each individual contours, right? cv2 dot moments find out the moments of individual contours. Cx for the centroid x, I mean along the row, and cy for along the column, right? For each contour, I'm going to find out the centroid of that contour, which would be a single point, and that single point is going to represent the entire information, right? Cx can be found out with a general formula, which is m10. You need not by heart these formulas; it is readily available in the internet, right? M00, right? So Cx, or the x part of the centroid, M10 by M00. Right? Then I'm going to copy paste this thing, Control C, Control V, and right now instead of M10 for Cy part, it would be M01. Hope it is understood. Right now we got the centroid of our contours. The next thing what we are going to do is draw a circle, right? CV2 dot circle. Okay. CV2 dot circle. So I'm going to draw it on my colored image, comma, I'm going to pass in the centroid Cx, comma, Cy as the center of my circle. Then I'm going to pass in 20 as the radius of, 20 pixels as the radius of the circle, right? Then I have to pass in the color. So BGR, maybe I should give it red color, 0, comma 0, B for 0, G for 0, and red 255. Comma, I'm going to give a 3 pixel thickness, right? So if I run this code, hopefully you can see that I have drawn circles around, my ant or the foreground element. Now you can definitely comment this draw contours out, and maybe it would be much pleasing if you are going to give the thickness of the circle being drawn as 2, or maybe you can give a different color, maybe 255. And if you run this, hopefully right now you are tracking it with yellow color, right? So this is how simple it is to do computer vision algorithm with the help of OpenCV and Python. So coding session ഇവിടെ അവസാനിക്കുകയാണ്. If you have any doubt on this, you can right now ask me. നിങ്ങൾക്ക് എന്തെങ്കിലും സംശയങ്ങൾ ഉണ്ടെങ്കിൽ you can ask. Anything? Any പ്രത്യേകിച്ച് എന്തെങ്കിലും സംശയങ്ങളുണ്ടോ? ചാറ്റ് ചെയ്താലും മതി. Any doubt? ആർക്കെങ്കിലും എന്തെങ്കിലും ചോദിക്കുകയാണെങ്കിൽ you can ask. Or if you don't, then I think I should continue. Sir, ഞാൻ continue ചെയ്തോട്ടെ എന്നാ?
Yes, sir. Yes, we can continue.
Okay. Now, the presentation കാണുന്നില്ലേ?
കാണുന്നുണ്ട്.
Okay, in any engineering task, even in computer vision, machine learning, deep learning, or whatever it may be, the first important thing is to understand the data. In what kind of data are you going to utilize? Which means your information. And based on this information, you are going to classify your relevant data and the noises, right? So in the previous case, I actually converted the colored image into a grayscale image, right? Because I only wanted to extract or localize or track the moving elements. What if I actually need to extract or localize a green moving element which have color? In that case, if I'm going to apply grayscale, it won't be a good idea, right? So before jumping into the programming side of computer vision task, you should actually understand what kind of relevant data you have, and you should actually brainstorm on the idea what kind of algorithms are you going to use. So that should always be kept in mind, and these things are basically called as what your system calibrations. And sometimes you have to make sure that your system is going to stick on with the parameters, or maybe you have to adjust some of the parameters. Anyway, let's continue. And two other things I would like to discuss about computer vision is augmented reality, and one is virtual reality. So augmented reality is basically introducing a virtual object into your 3D real world, right? So നിങ്ങൾക്ക് ഈ image നോക്കി മനസ്സിലാവും, a person is having a mobile phone and he's taking a photo. And with the help of his smartphone, he's placing a sofa inside his field of view, right? Maybe he want to look, ensure that how would a blue sofa would look, would it be better if I keep a blue sofa in there or not? അതായത് അങ്ങനെ ഒരു ബ്ലൂ സോഫ വെച്ചാൽ അവിടെ എങ്ങനെ ഇരിക്കും, അവിടെ സ്പേസ് ഉണ്ടാവും. Maybe these kind of things can be used, understood with the help of augmented reality. You might have seen, Snapchats where you place mustaches അല്ലെങ്കിൽ കണ്ണാടികൾ വെക്കുന്ന സ്നാപ്ചാറ്റ് വീഡിയോസ് നിങ്ങൾ കണ്ടിട്ടുണ്ടാവും, right? So basically these all are kind of related with augmented reality, but one thing is sure is that you should understand the orientation. അല്ലെങ്കിൽ the computer vision algorithm running behind this mobile phone for placing this sofa should have a better understanding of how the room is oriented. അതിന്റെ ഓറിയന്റേഷൻ വ്യക്തമായിട്ട് മനസ്സിലായില്ല എന്നുണ്ടെങ്കിൽ ഈ സോഫ ഒരു പക്ഷെ തല തിരിഞ്ഞാവിരിക്കുക. Right now it looks like the sofa is right there because based on the orientation extracted from the image, the sofa should be oriented somewhat or aligned with those orientation of the room, right? That is the idea. So basically in augmented reality applications, your device should have an orientation sensor, maybe a compass, right? There are even marker based orientation estimation with the help of augmented reality. അപ്പോൾ നിങ്ങളിപ്പോൾ ബാർകോഡ് അനലൈസ് ചെയ്യുകയാണെങ്കിൽ അല്ലെങ്കിൽ അങ്ങനത്തെ കോഡൊക്കെ യൂട്ടിലൈസ് ചെയ്തിട്ട് നിങ്ങൾ ചിലപ്പോൾ ഈ ടൈഗർ അല്ലെങ്കിൽ ചെറിയ augmented reality applications റൺ ചെയ്തിട്ടുണ്ടാവും. And with the help of those barcodes, we are actually extracting the orientation information, right? And there are markerless augmented reality. In the case of facial detection, if you are using facial landmark detection, നിങ്ങൾക്ക് നിങ്ങളുടെ മൂക്ക്, കണ്ണ്, വായ അങ്ങനത്തെ ഫേഷ്യൽ ഫീച്ചേഴ്സ് എവിടെയാണെന്ന് മനസ്സിലാക്കാൻ സാധിക്കും. ആൻഡ് വിത്ത് ദോസ് ഇൻഫർമേഷൻസ് യു ക്യാൻ പ്ലേസ് മുസ്റ്റാഷസ്, അല്ലെങ്കിൽ മീശ അവിടെ വരയ്ക്കാൻ സാധിക്കും, അല്ലെങ്കിൽ കണ്ണുകൾ അവിടെ വരയ്ക്കാൻ സാധിക്കും. So basically understanding augmented reality is pretty much simple. So all you need to have is a greater grasp on the understanding on how computer vision works. And computer vision is really a very simple task. So you can do computer vision, basically just with the ideas, if you have the right ideas. Right? The next thing is virtual reality. The reality in the case of virtual world, in this case, in the virtual reality case, the reality would be entirely synthetic. The world you are going to see would be entirely synthetic, and you might be using a virtual reality boxes, VR box, and those VR boxes are available online for free. Now, the basic understanding of virtual reality is that you would be having a compass, again, maybe an orientation sensor, so that when you make a tilt or tilt your head or nod your head, you can understand that there should be a variation in the scenes you are seeing through your virtual reality boxes. And based on that, based on that information from the sensors, you are going to render new world, right? So that is the idea. If you have played PUBG പോലത്തെ ഗെയിം ഒക്കെ കളിച്ചിട്ടുണ്ടെങ്കിൽ ആ ഗെയിമിൽ എൻറ്റയർലി മാപ്പ് മൊത്തമായിട്ട് ഇപ്പോൾ ആസ് എ പ്ലെയർ മൂവ്സ് ആ മാപ്പ് മൊത്തമായിട്ട് നമ്മൾ റെൻഡർ ചെയ്യുന്നില്ല. ആ പേഴ്സന്റെ പർട്ടിക്കുലർ ഫീൽഡ് ഓഫ് വ്യൂവിലുള്ള മാപ്പ് മാത്രമാണ് നമ്മൾ റെൻഡർ ചെയ്യുന്നുള്ളൂ. പിന്നെ ആ പേഴ്സൺ തിരിയുമ്പോൾ വീണ്ടും റെൻഡറിങ് നടക്കുകയാണ്. അപ്പൊ അത്രയും പാർട്ട് മാത്രമാണ് നമുക്ക് ആക്ച്വലി റെൻഡർ ചെയ്യേണ്ട കാര്യമുള്ളൂ. അത് തന്നെയാണ് വിർച്വൽ റിയാലിറ്റിയുടെ കേസിൽ നടക്കുക. ഇഫ് യു ടിൽറ്റ് യുവർ ഹെഡ് and based on that tilt you are experiencing a new field of view, right? I hope the idea of virtual reality is clear now. Now let us start discussing about robots, types and their applications, and after that I think I should indulge with a bit of concept of robotics. So let us start with the most basic type of industrial robots. These robots are having joints, links and end effectors. The first image to come to your mind would be these kind of pick and place robots, and mostly I would be quick on the part of different kinds of these type of robots, because mostly these type of robots you might have seen, right? കണ്ടുപരിചയമുള്ള കാര്യങ്ങളാവും, അതുകൊണ്ട് I would be rather quick, right? Now one thing I should discuss about is the end effectors, അല്ലെങ്കിൽ tool ends എന്ന് പറയും. So these tool ends or end effectors are going to grasp your work material. And the choice of these end effectors depends on the type of industry you are employing these robots in. So if you are going to use these robots or employ these robots in the case of glass sheet manufacturing industry, you might use a suction cup. If you are using these robots in automobile assembly lines, you might be using a gripper, welding machine or a drilling machine. It depends, right? Anyway, another parameter I think I should discuss is the three-dimensional work volume. The work volume is that three-dimensional space around this robot which this robot can access. അതായത് ഇതിന്റെ എൻഡ് എഫക്ടറിന് അല്ലെങ്കിൽ ഇതിന്റെ ടൂൾ എൻഡിന് അതിന് ചുറ്റും എത്തിപ്പെടാൻ പറ്റുന്ന 3-dimensional ആയിട്ടുള്ള വർക്ക് മീൻ സ്പേസിനെയാണ് വർക്ക് വോളിയം എന്ന് പറയാം. Right? Now, extending on these robots, mostly these kind of industrial robots would be caged. കൂട്ടിലിട്ട് വെച്ചിട്ടുണ്ടാവും to prevent the accidental entry of human beings into their work volume. അങ്ങനെ അവിചാരിതമായിട്ട് ഒരു വ്യക്തി അതിന്റെ വർക്ക് വോളിയത്തിന്റെ ഉള്ളിൽ കയറി കഴിഞ്ഞാൽ ഈ റോബോട്ട് ഒരു പക്ഷേ അറിയാതെ ഈ ഹ്യൂമൻ ബീയിങ്ങിനെ ഹേർട്ട് ചെയ്യാനുള്ള സാധ്യതകളുണ്ട്. Because these robots won't be having kind of 3D volume understanding capability. കാരണം these robots are meant to work for 24/7, right? അതിന്റെ ഇടയിൽ interruption ആവശ്യമില്ലാത്തൊരു കേസ് ആവും, normally to maintain the chain of work. So to avoid such unfortunate situations, you employ a cage around these robots, right? Anyway, the basic or the most influential industry players are KUKA, FANUC, ABB, right? The next I would like to discuss about our collaborative robots. These are called cobots, right? And so cobots are basically a miniature version of these industrial robots. So the basic dynamics or the kinematics associated with these robots are similar to that of industrial robots. And the most number of job providers in the field of robotics are collaborative and industrial robots, right? But one advantage of collaborative robots is that it has got 3D world readability, which means it is expected to share its work volume with human beings. Normal case, industrial research based ആയിട്ടുള്ള purposes അല്ലെങ്കിൽ quality inspection, machine tending, you can see these kind of collaborative robots. So if you have seen Iron Man movies, the collaborative robots are actually helping Iron Man suit and unsuit, right? So that is one example of collaborative robots. The next are companion robots. So these are mostly meant to act as companions. Mostly these would be artificially intelligent, definitely intelligent. These robots are meant to act as companions, which means right now we have this social awkward condition that we all are kind of busy and we don't want our parents or kids to have this feeling of being left alone. നമ്മൾ കമ്പാനിയൻ റോബോട്ട്സിനെ സമൂഹത്തിലോട്ട് ഇൻട്രൊഡ്യൂസ് ചെയ്യുന്നത്. So definitely these should be artificial intelligence. കാരണം it should be able to behave accordingly. അതായത് it should be able to understand the emotions of the person he is talking with. Then based on that emotions, he should have feedback system and behave accordingly. അല്ല ഇപ്പൊ നിങ്ങൾ ആൻഡ്രോയിഡ് കുഞ്ഞപ്പം കണ്ടിട്ടുണ്ടെങ്കിൽ അതിന്റെ ബേസിക് ആയിട്ട് കമ്പാനിയൻ റോബോട്ട് എന്ന് പറയുന്ന കൺസെപ്റ്റ് ആണ്, റൈറ്റ്? And normally these kind of robots would have vision, audio, speech, 3D world capability. They're a high-end robot, and there are a lot of fundings coming this way. There are a lot of startups actually doing work on companion robots, because we are talking about robots that can be your future house companions, like future family members avan helpful robotic system ine kurichana nammalippo സംസാരിച്ചുകൊണ്ടിരിക്കുന്നത്. If you have seen Big Hero 6, basically these kind of robots comes under the idea of companion robots, right? So intelligence is one important parameter in the case of companion robots. Now the next thing is medical robots. This image on the left is particularly of Da Vinci surgical systems. One thing you cannot actually compromise is the accuracy of precision, because a doctor or a surgeon sitting in America can actually do a surgery of a person or a patient in India. So mostly these would be joystick controlled. Right now we are not going to look into the artificial intelligence case of the system, because we can't afford. And most importantly, artificial intelligence has got a general stream of generalization, right? Anyway, one of my friends is actually working in SS Robotics. So they are developing their own medical robots. So he's saying that they have spent huge amount of money just to produce or make a prototype of these kind of robots, almost more than 500 crores, I think. So if you are actually, if any of you are interested in the field of medical robots, you can definitely go with this career in your mind, because it's going to give you more pay, more respect, and all those things. So the next thing, next type of robots is prosthetics. So prosthetics is that field of robotics where you get to replace your lost limb or amputated arm or maybe amputated leg with a robotic counterpart. Now, I have worked on prosthetics. So basically, The major challenge in the field of prosthetics is the placement of sensors and actuators. You can see the fingers are having 3 joints. So one is that you can employ each actuators for each joint. In that case, for an arm, you might have 15 actuators. So our 15 actuators afford controller you should have, and the algorithm definitely would be complex, right? If you can think about it, right? And there are constraint systems. Instead of individual actuators for individual joints, you can actually use a single joint. Occasionally, string actuated systems like carbon fiber springs you can use. But one important thing about these robotic system is that it should have a good data acquisition system. Data acquisition system or rainbow, we are talking about replacing an involuntary or voluntary muscular actions with the help of a robotic counterpart. In that case, you need to extract electroencephalograms, or maybe electrocardiograms, or maybe electromyograms. Definitely electromyograms. അതായത് മസിൽ സിഗ്നൽസ് ഇവിടെ എക്സ്ട്രാക്ട് ചെയ്യേണ്ടതായിട്ടുള്ള ആവശ്യം വളരെയധികം ഉണ്ട്. In that case, you would have to definitely use a data acquisition system to extract EMG information, and then you can maybe train a machine learning algorithm or maybe a neural network, and then pass the output to the actuators. Now, if you have a prosthetic limb, would you be considered as a cyborg? No, cyborgs are entirely different cybernetic organisms. You having a prosthetic arm doesn't make you a cyborg. Cyborgs are self-regulating integration of artificial and natural systems. Normally I would be controlled by my brain or maybe my central nervous system. എൻ്റെ ഓരോ ചലനങ്ങളും എൻ്റെ സെൻസേഴ്സും എൻ്റെ ആക്ടിവേഷൻ എല്ലാതും കൺട്രോൾ ചെയ്യുന്നത് എൻ്റെ ബ്രെയിൻ ആയിരിക്കും. But what if I bypass those control from brain to a microcontroller? In that case, I could be considered as a cyborg. The image on the left is actually a cyborg beetle, which was developed at Cyborg Research Facility. I think it is in Singapore, and they actually manipulated its flight. So whoever interested bit of biology and this kind of robotics, you can always go for cybernetic studies and research. For the defense field, utilize there are a lot of researches going on. Anyway, so if you want to know more about these, you can find these videos in the YouTube. And also, one thing is that it won't be, I don't know whether it is that job oriented, but definitely there are a lot of research opportunities in this field, right? Now, definitely you might be knowing about humanoids. I'm not going to explain much about Sophia. So Sophia is artificially intelligent. She is made by Hanson Robotics. You might have seen her interacting with people, and she is actually a thing of beauty, right? And she's the only robot who was granted citizenship by Saudi Arabia, right? So my personal favorite is biomimicking robotics. So one of the greatest players of Festo. For biomimetic robotics, you should have a thorough internet search or YouTube search. So basically, then you came out with the idea of aerofoils. Because flapping wings were not possible at that time, right? But now we can see these kind of butterflies flying, maybe birds flying. So Festo is literally making these kind of biomimetic organisms. A lot of them, literally, they have a biomimetic bat, these butterflies, dragonflies, kangaroos, snakes, fishes, and almost they are literally making a biomimetic zoo or robotic zoo out of these biomimetic organisms. So the one important question that is engineering relevant is that why should we actually consider making biomimetic systems when our already established systems are efficient? So if you are going to replace an engineered system with another solution, then it should be better efficient, right? And recently I have been going through a few of the research papers on biomimetics or biomimicry. So they were actually studying on the efficiency of propulsion system. I mean, how the ships are propelling and the fishes are propelling. So ships use their propellers, which are going to rotate, and the fishes use their tail flapping motion, right? Surprisingly, the study found out that the fish is 80% more efficient compared to the ship in propulsion with respect to propulsion. right? So there are a lot of advantages in the case of biomimicry. Now, I would like to give you a few more understanding why biomimicry should be used. So maybe you down Japanese obsession with super fast trains. For previous case, the trains in the Indian train flat faces are they tried to make their trains super fast. But the problem with those super fast trains were that trains tunnel the air inside the tunnel get excessively compressed. The train the compressed air expands suddenly, creating a loud explosive noise. This efficiency and speed. So a lot of engineers and scientists took it up to themselves and they came up with a solution. And the solution was to replace the flat face mimicking the shape or the face of a kingfisher, right? Kingfisher dive ചെയ്യുന്നത് നിങ്ങൾ ശ്രദ്ധിച്ചിട്ടുണ്ടെങ്കിൽ മനസ്സിലാവും അവിടെ pressure infinity ലോട്ട് പോകുന്നുണ്ട്, അതായത് പോസ്റ്റ് ബൈ ഏരിയ സീറോയിലോട്ട് എത്തുന്നുണ്ട്, റൈറ്റ്? കാരണം കിങ്ഫിഷറിന്റെ സ്നൗട്ട് അല്ലെങ്കിൽ ബീക്കിന്റെ എൻഡ് പോയിന്റഡ് ആണ്, റൈറ്റ്? And also I have been going through another paper. A person, not a person, a group of scientists actually made a biomimetic microorganism, a robotic organism. And these organisms are going to feed on algae. Algae feed a gut in stomach. Then these are going to feed on algae and produce energy. So we are actually talking about replacing the entire battery systems with robotic guts or maybe robotic stomach. We are going to talk about waste management if these robots are able to consume all the waste. I hope you got the magnitude of what I'm talking, because we are actually talking about our robots running forever, right? Without drain of battery, because when it is able to feed for itself, then we are actually assuming or achieving a certain other milestone that human beings are yet not capable of. Anyway, that is one reason why LEAP is actually in the, I mean, we are going to start our research oriented thing in biomimetics. Right, there are swarm robotics. This also is a basic part of biomimetics. So coordination of multiple robots. We are talking about swarm intelligence, how the ants are collecting food. There are locust sprays, there are a swarm of flies, there are a swarm of birds. We can use them in even B2B vehicle technologies. Anyway, it can be used for optimization problems. Now there is another field called soft robotics. It is mostly inspired from octopus, because the tissues or the exoskeleton are kind of soft gelatinous tissues, materials, and right now they are using silicon epoxies. So you can create your own silicon epoxy based grippers. Right now there are a lot of industries actually shifting their hard grippers, metal grippers, into these soft robotic grippers, and they are as efficient as those hard grippers, right? And also mostly they would be using air or fluid filled actuation methodologies. So this is going to have a greater reaction time. So it is possible that these things are really slow, right? In the parallel, there is these micro vault technologies that are blooming, right? So if you are interested, you can go through them. Anyway, I'm not going to discuss about drones because all of you know about drones, and most importantly, you cannot actually skip the webinar without drone. So I just have included drones, right? Now, discussion on robotics wouldn't be completed. We are not actually discussing about 3D printing technology. A 3D printer is kind of every engineer's dream. Additive manufacturing technology into material removal methodologies. And right now, the 3D printers you can get available like Ultimaker, Ultimaker, Prusa. Mostly they are using additive printing technologies. The filaments in the PLA are ABS are wooden filaments are maybe metal filaments are manho. Companies they are giving you this facility. But the most important thing is that these can be used for rapid prototyping. So if you are interested in kind of business or maybe in startup, you would like to check out the viability of your product or apply for a patent, then you can definitely go with 3D printers. And eBay Alibaba 3D printers 10,000 rupees. പക്ഷെ അത് ഷിപ്പ് ചെയ്യാൻ വേറെ 10,000 കൊടുക്കേണ്ടി വരും, അതാണ് പ്രശ്നം. But I would suggest you start using AutoCAD Fusion 360, one of the good 3D modeling software. Utilize it I suggest you start using them. Modeling not a place robotics, not a good place. You can start using Fusion 360. It is kind of addictive. Interesting on Fusion 360. Anyway, recently almost everything is 3D printed. If you go on an internet research, you can find muscle cells, heart walls all being 3D printed, right? Now, I would like to discuss only one more slide, I think, right? I would like to discuss a bit about robotics. So, discussing about robotics is a great field, and we cannot complete it without, discussing a whole lot of things. But anyway, I'm going to strictly restrict myself within the bounds of what we call the system design. So, what are actually making robots possible? You need sensors. Your robot need to see or understand things, maybe hear things. And to respond to those environmental changes, you need to have actuators. And these information are being processed inside what you call as your controller, right? Okay. So basically, there are dynamics or kinematics, or maybe human robot interface associated with these robots. Now, all these comes under what you call as system design. Basically, നിങ്ങളുടെ റോബോട്ട് എന്താണെന്നുള്ളതും ആ റോബോട്ട് എങ്ങനെയൊക്കെ ഏതൊക്കെ എൻവയോൺമെന്റൽ സാഹചര്യത്തിലാണ് ആ റോബോട്ടിനെ ഇംപ്ലിമെന്റ് ചെയ്യാൻ പോകുന്നതെന്നും ആ റോബോട്ട് ഏതെല്ലാം തരത്തിലുള്ള സ്റ്റിമുലസ് നേരിടാം അതിനെല്ലാം എങ്ങനെ റെസ്പോണ്ട് ചെയ്യണം എന്നുള്ളത് നിങ്ങളുടെ ഒരു ഔട്ട്ലുക്കാണ്. ആ നിങ്ങളുടെ ഔട്ട്ലുക്കിനെയാണ് നമ്മൾ ബേസിക്കലി സിസ്റ്റം ഡിസൈൻ എന്ന് പറയുന്നത്. So I'm going to explain system design with the help of a single an example. But before that, Da Vinci once told the man and the intention of his soul. A great artist always paint two things: the man and the intention of his soul. Rather, if you are going to be in robotics, you should have a great software, and you should have a good what you call the hardware or exoskeleton for the purpose. Anyway, extending on system design, assume that I would like to build a robot. A robot in the room clean and robot on. The first thing is that it is a cleaning robot and it should have a cleaning apparatus. Right, the first actuator in the suction pump, right? In the actuator section, I'm going to write in suction pump. Then the second thing is that my robot should be scanning the entire room. In that case, it should have wheels which should be hooked onto your processors, like wheels and motors and down. So if you are going to connect your motors onto your microcontroller and ask your robot to run along a straight line, then you are expecting your robot to run along a straight line. But it is not going to do that. It is going to turn or make a bend because the intrinsic parameters of this motor might vary. The motor, robot in a drive in the motors, in the intrinsic parameters, right? And inductance, the resistance, definitely item vary. It is going to extract different current from the motors. Different motors are going to have different currents. If it is going to extract different currents, in that case, definitely your motors are going to have different RPMs, rotations per minute. And different rotations per minute, and it's going to take a turn. In that case, you need to apply another controller, maybe a PID or a fractional PID. Definitely, you can use a PID controller, right? Now, one thing else is that if you have made your robot move along a straight line and you can find obstacles, you are going to hit obstacles. Your robot might hit obstacles. So obstacle detection and you have a lot of range of sensors: ultrasound, infrared, lidar, radar, computer vision, right? Camera. Lidar and radar long range sensors. Definitely you need not use that. Room into work keeping the ultrasound, infrared, you can employ that, right? Obstacle detect, you should have an obstacle avoidance algorithm, how you are going to maneuver these obstacles. Most importantly, there is what you call as sensor data fusion. Camera could utilize autonomous vehicles in the case robotics in the case you're going to use sensor data acquisition, ക്യാമറയും അതോടൊപ്പം തന്നെ ഒരു ഒബ്ജക്ട് ഡിറ്റക്ഷൻ സെൻസറും അല്ലെങ്കിൽ ഒബ്സ്റ്റക്കിൾ ഡിറ്റക്ഷൻ സെൻസറും നിങ്ങൾ simultaneously utilize ചെയ്യും. Then only you can make what you call as your SLAM algorithm, simultaneous localization and mapping. So if your robot is autonomous, it should have a working SLAM algorithm. അതല്ലാന്നുണ്ടെങ്കിൽ you should always have to run with a joystick behind your robot. കാരണം നിങ്ങളിപ്പോൾ നമ്മുടെ സ്റ്റാർട്ടപ്പ് മിഷന്റെ കീഴിലുള്ള ഏത് റോബോട്ടിക് സിസ്റ്റം എടുത്ത് നോക്കിയാലും മോസ്റ്റ്ലി യു ക്യാൻ ഫൈൻഡ് ഗൈസ് ഹാവിംഗ് എ ജോയ്സ്റ്റിക് ദേ ആർ മേക്കിംഗ് ദെയർ റോബോട്ട്സ് മൂവ്. അതിനിപ്പോൾ എഞ്ചിനീയറിംഗ് പഠിക്കേണ്ട അത്ര വലിയ ആവശ്യമുണ്ടെന്ന് എനിക്ക് തോന്നുന്നുണ്ട്. ദ മോസ്റ്റ് ഇമ്പോർട്ടൻറ്റ് തിങ് ഈസ് ദാറ്റ് ഇറ്റ് ഷുഡ് ബി ഓട്ടോണോമസ്. ഇറ്റ് ഷുഡ് ഹാവ് എ സ്ലാം, സൈമൾട്ടേനിയസ് ലോക്കലൈസേഷൻ ആൻഡ് മാപ്പിംഗ് എന്ന് പറഞ്ഞാൽ ഈ റോബോട്ടിന്റെ ചുറ്റുമുള്ള എൻവയോൺമെന്റിൽ എന്തൊക്കെയാണ്, അത് എവിടെയെല്ലാമാണ് എന്നുള്ള ഇൻഫോർമേഷൻ ഈ റോബോട്ടിന് കൊടുക്കുന്നതിനാണ് സ്ലാം എന്ന് പറയുന്നത്. If you have SLAM, then only you can do path planning. അതായത് ഈ റോബോട്ടിന്റെ ഡെസ്റ്റിനേഷൻസ് ആൻഡ് അതിനെ കാൽക്കുലേറ്റ് ചെയ്തിട്ട് അതിന്റെ എഫക്റ്റീവ് ആയിട്ടുള്ള പാത്ത് എങ്ങനെ പ്ലാൻ ചെയ്യാം. ഇത് പാത്ത് പ്ലാനിങ് നടന്നില്ല എന്നുണ്ടെങ്കിൽ യുവർ റോബോട്ട് ഇസ് ഗോയിങ് ടു സ്കാൻ ദ എൻറ്റയർ റൂം അഗൈൻ ഇൻ ദ ഗെയിം വിത്തൗട്ട് എ പർപ്പസ്. So a working robotic system should have ransack, അതായത് random sample consensus എന്ന് പറയും. അതായത് unwanted noisy data അവോയ്ഡ് ചെയ്യുന്ന ഒരു algorithm ആണ്. Then it should have SLAM, simultaneous localization and mapping. Then definitely it should have a path planning algorithm. That makes your robot what we call as autonomous robots. Adallanundengil you can sit on a chair, you can use your joystick to control your robot, which means your robot is definitely blind. And if you are going to control your robot with what you call a joystick, you need not actually use any of these sensors like camera or object detection or obstacle detection sensors. അതിന്റെ ആവശ്യം നിങ്ങൾക്ക് വരില്ല. കാരണം നിങ്ങളുടെ ഈ സെൻസേഴ്സ് എല്ലാം ചെയ്യുന്ന കാര്യങ്ങൾ നിങ്ങൾ ഒരു ജോയിന്റ് ചെയ്യുന്നുണ്ട്, റൈറ്റ്? So that's the idea. So I think that's it. I'm going to ഇത്രയേ ഉള്ളൂ. നിങ്ങൾക്ക് ഇനി എന്തെങ്കിലും ഡൗട്ട് ഉണ്ടെങ്കിൽ നിങ്ങൾക്ക് ചോദിക്കാം. And I recommend you should visit our site. Kind of ransack, SLAM, and path planning we are covering through our internship programs, and we are conducting our 2-month, 3-month programs on Python, fuzzy logic, computer vision, robotics. So if you are interested, you can definitely join, contact us, right? ഇനിയിപ്പോൾ നിങ്ങൾക്ക് എന്തെങ്കിലും സംശയങ്ങളോ കാര്യങ്ങളോ ഉണ്ടെങ്കിൽ you can definitely ask. നിങ്ങൾക്ക് ചോദിക്കാം. Anyone? അല്ലെങ്കിൽ ചാറ്റ് ചെയ്യാം. എന്തെങ്കിലും സംശയങ്ങൾ ഉണ്ടെങ്കിൽ definitely you should ask.
Students, if you are in doubt, you can ask now.
എല്ലാവരും ഓർമ്മയാണോ?
I think nobody has the doubt. Okay. Okay, then I will ask one doubt.
Okay.
So your actually scanning has been done with white background and black color and. So
Yes.
if the colors are both are black, so how will you identify the system?
അതും കുഴപ്പമില്ല സാർ. കാരണം എന്താണെന്ന് വെച്ചാൽ നമ്മൾ ബാക്ക്ഗ്രൗണ്ട് സബ്ട്രാക്ഷൻ ആണ് നടത്തുന്നത്. ബാക്ക്ഗ്രൗണ്ട് സബ്ട്രാക്ഷൻ എന്ന് പറഞ്ഞാൽ സ്റ്റേബിൾ ആയിട്ടുള്ള എല്ലാത്തിനെയും നമ്മൾ എലിമിനേറ്റ് ചെയ്യും, മൂവിങ് ആയിട്ടുള്ളതിനെ എക്സ്ട്രാക്ട് ചെയ്യും. പക്ഷെ സാർ ഇപ്പൊ ചോദിച്ചൊരു ചോദ്യത്തിൽ മറ്റൊരു പ്രശ്നമുണ്ട്. ഇപ്പൊ ആസ് എ ഹ്യൂമൻ ബീങ് നമുക്കിപ്പോ കാണാൻ സാധിക്കുന്നില്ല എന്ന് വിചാരിക്കുക. അതായത് ഡാർക്ക് ബാക്ക്ഗ്രൗണ്ടിൽ ഡാർക്ക് ആൻഡ് മൂവ് ചെയ്യുന്നത് നമ്മുടെ ക്യാമറയ്ക്കും കാണാൻ സാധിക്കില്ല. കാരണം സെയിം ലൈറ്റ് റേസ് ആണ് നമ്മുടെ കണ്ണിലോട്ടും സെയിം ലൈറ്റ് റേസ് ആണ് നമ്മുടെ ക്യാമറയിലോട്ടും എത്തുന്നത്.
ഓക്കെ, അതെ എൻ്റെ ക്വസ്റ്റ്യൻ. സെയിം ഓബ്ജക്റ്റ് സെയിം കളറിലാണെങ്കിൽ ഇവൻ എന്തോ മൂവിങ് ആണെങ്കിൽ നമുക്ക് അത് ഐഡന്റിഫൈ ചെയ്യാൻ പറ്റത്തില്ല. അതിലേതെങ്കിലും ഇമേജ് പ്രോസസിംഗ് മെത്തേഡ് എന്തെങ്കിലും കറന്റ് യൂസ് ചെയ്യുന്ന?
അതായത് വി മൈറ്റ് യൂസ് ഡിഫറെന്റ് ഹാർഡ്വെയർ. അതായത് ചിലപ്പോൾ IR ക്യാമറാസ് യൂട്ടിലൈസ് ചെയ്യേണ്ടി വരും, ഡിഫറെന്റ് ആയിട്ടുള്ള ക്യാമറ യൂട്ടിലൈസ് ചെയ്യേണ്ടി വരും, അല്ലെങ്കിൽ പിന്നെ ഡെപ്ത് ഡിറ്റക്ഷൻ സെൻസേഴ്സ് യൂട്ടിലൈസ് ചെയ്യേണ്ടി വരും. അങ്ങനെ പിന്നെ ഈവൻ മൈക്രോസ്കോപ്പിക്കൽ ലെവലിൽ നമ്മൾ യൂട്ടിലൈസ് ചെയ്യുകയാണെന്നുണ്ടെങ്കിൽ ഇപ്പോൾ നമ്മൾ ഈ മില്യൺസ് ഓഫ് സെൽസ് കൗണ്ട് ചെയ്യുന്ന കാര്യമൊക്കെ മൈക്രോസ്കോപ്പ് വെച്ചിട്ട് ചെയ്യാറുണ്ട്. അതിന് അതിൻ്റെതായിട്ടുള്ള ഡിഫറെന്റ് ഹാർഡ്വെയർസ് വേണം. നമുക്ക് അൽഗോറിതത്തിൽ മാത്രമല്ല മാറ്റം കൊണ്ടുവരാൻ സാധിക്കുക. വി ക്യാൻ ഇംപ്ലിമെന്റ് ഇറ്റ് വിത്ത് ദ ഹെൽപ്പ് ഓഫ് ഹാർഡ്വെയർ സപ്പോർട്ട്.
Okay. Okay, thank you. I hope nobody has the doubt.
Sir, ഞാൻ ഫീഡ്ബാക്ക് ഫോമിന്റെ ലിങ്ക് ഇതിലിടുകയാണോ?
ഓക്കെ, അതിനകത്തിടാം.
അല്ലെങ്കിൽ ഞാൻ സാറിന് പേഴ്സണൽ മെസ്സേജ് അയച്ച് ഇവർക്ക് അയച്ചു കൊടുത്താൽ മതി.
അല്ല, ജസ്റ്റ് ഇപ്പം കമന്റ് ബോക്സിൽ ഇട്ടോളൂ. അപ്പൊ പിന്നെ ഇപ്പൊ തന്നെ ഉള്ളവർക്ക് ഫീഡ്ബാക്ക് തരാലോ. ഇറ്റ് വിൽ ബി ഈസി. ചാറ്റ് ബോക്സിനകത്ത് ഇട്ടാൽ മതി. താഴെ ബോട്ടം പൊസിഷനിൽ ചാറ്റ് എന്ന് പറഞ്ഞ ഓപ്ഷൻ ഉണ്ട്, പാർട്ടിസിപ്പന്റ് അടുത്തായിട്ട്. Yes, sir. Actually, our principal is there. Actually, hand out to principal.
ഗുഡ് ഈവനിങ്. എനിക്ക് കാര്യം പറഞ്ഞാൽ ഫുൾ അറ്റൻഡ് ചെയ്യാൻ പറ്റില്ല. സ്റ്റാർട്ടിങ്ങിലൊന്ന് കയറിയിരുന്നു, കുറച്ച് തിരക്കായിരുന്നു. ഓക്കെ വിപുൽ, താങ്ക് യു വെരി മച്ച് ഫോർ യുവർ വാല്യുബിൾ ടൈം വിത്ത് us.
Thank you, sir.
I think the session will give some idea about the robotics and computation. Am I right? Computer vision, yeah, exactly. And I saw that augmented reality, etc. Discussed in the session, അല്ലേ?
Yes, sir.
കുറച്ചുകൂടെ ഞാൻ കണ്ടിരുന്നു. ഞാൻ ഇടയ്ക്കൊക്കെ ഒന്ന് കയറിയിരുന്നു, പക്ഷെ ഞാൻ കുറച്ച് തിരക്കിലായിപ്പോയി, അതുകൊണ്ടാണ്. ഓക്കെ, വിർച്വൽ റിയാലിറ്റി, ഓഗ്മെന്റഡ് റിയാലിറ്റി എല്ലാം കുറച്ചൊക്കെ പറയുന്നത് ഞാൻ കണ്ടിരുന്നു. ഓക്കെ, വെരി ഗുഡ്. അപ്പോൾ സ്റ്റുഡൻസിന് ഒത്തിരി ഹെൽപ്ഫുൾ ആവുമെന്ന് ഞാൻ വിചാരിക്കുന്നു. ഡെഫിനറ്റ് ആയിട്ട് ഞാനത് എന്താ റെക്കോർഡ് ചെയ്തിട്ടുണ്ട്. ഓക്കെ, സോ ദാറ്റ് ഇനി സ്റ്റുഡൻസ് എന്തെങ്കിലും കാണുന്നുണ്ടെങ്കിൽ ഐ വിൽ ഗിവ് ദ ലിങ്ക് ടു ദം. ഓക്കെ, താങ്ക് യു വിപുൽ.
Thank you again, sir. And thank you all.
Okay, thank you for your session, sir. Okay. Students, you can also fill the feedback form that is actually put in the chat box.
ഒരു കാര്യം ചെയ്യും, അഖിലിനെ ഒന്ന് വാട്സാപ്പിൽ അയക്കുകയാണെങ്കിൽ അഖിൽ ബാക്കി അവർക്കൊന്ന് അയച്ചു കൊടുക്കാൻ
ഞാൻ അത് അയച്ചു കൊടുക്കണം. ഇപ്പം ജസ്റ്റ് ഇവിടെ ലൈവ് ആയിട്ടുള്ളവർക്ക് ചെയ്യാൻ വേണ്ടി.
ഓക്കെ.
ഞാൻ മീറ്റിംഗ് ലീവ് ചെയ്താൽ ഞാൻ ചാറ്റ് ചെയ്ത് പോകുമെന്ന് എനിക്കറിയില്ല.
ഇല്ലല്ലോ, പോകത്തില്ല. ജസ്റ്റ് അവിടെ റിമൈനിങ് ആയിട്ട്.
ഓക്കെ, താങ്ക് യു, സർ. ശരി.
ഓക്കെ, താങ്ക് യു ഫോർ.
ഓക്കെ, ശരി. ഞാനൊന്ന് എൻഡ് ചെയ്തോട്ടെ?
സർ, കഴിഞ്ഞു.
ഓക്കെ, ശരി.
യെസ്, സർ.